Hello friends, welcome to this session. Today we are discussing regarding the high rate filters. Along with that, we are also discussing regarding the filter troubles, head loss in filters and negative head. Now, as we have discussed earlier, the regular filters, there are slow sand filters, rapid sand filters. Okay, so many types of filters are there, but nowadays the high rate filters are becoming popular because of the high rate of filtration. Uh, then, along with that, uh, when the filtration is in the process, so after some time, as we have discussed earlier, that clogging of the particles or clogging of the different layers that may take place, and such problems may occur in the filtration process. And along with the filtration process, the filter troubles have to be studied, so that how to overcome this, that also to be studied properly. Then we'll have to study regarding the head loss in the filter and negative head also. So let's start for today's session. High rate filters. High rate filters which operate at 3 to 4 times the rate of rapid sand filters use a combination of filter media, not just sand. Media combinations are generally sand and anthracite coal. Multimedia or mixed media filters generally used sand, anthracite coal and garnet. In rapid sand filters, fine sand grains are at the top of the sand layer with the layer grains further down the filter. As a result, the filter removes most suspended material in the first few inches of the filter. In the high rate filter, the media size decreases and the top layers consist of coarse material with the finer material further down, allowing the suspended material to penetrate deeper into the filter. This allows for longer filter runs at higher rates than is possible with the rapid sand filters. Filter media used in the high rate filter depends on the raw water quality, raw water variations and raw water variations and which allows a chemical treatment used. Pilot studies help the operator evaluate which material and combination of materials will give best results. Now you can see here two configurations of the high rate filters. So in this first cross section of the filter, you can what you find here, it is a dual media filter. So where coal, sand, gravel, okay, these are the various layers which are used. You can see here the water level here. Okay, so such type of filter is called as a dual media filter. Then multimedia or mixed bed filter, so in which the combination of the various filter media that can be done. So here in this cross section, you can find the different coal, sand, garnet, gravel. Okay, such combination can be made, and such particular filters are known as a multimedia filter or mixed bed filters. Okay, let's have the detailed discussion on the pressure filter. So obviously by the name itself, it is clear that it is carried out with the pressure filter. Then it consists of a you can say a typical vessel in which all this media is included, and as we have discussed, the media is exactly placed as per the requirement of the flow rate requirement at the outlet. So here you can observe the inlet is provided here. Okay, this is the distribution system is there, and in this vessel, right, different media is there for the outlet. These perforated pipes are provided here, and the operation at the bottom for the more rigidity, the concrete base is provided. So for getting the results, this is operated under the pressure. Now pressure filters fall into two categories of pressure sand filter and diatomaceous earth filters. Pressure filters are used extensively in iron and manganese removal plants. A pressure sand filter is contained under a pressure in a steel tank, which may be vertical or horizontal depending on the space available. As with gravity filters, the media is used sand or combination of media, and filtration rates are similar to gravity filters. Groundwater is first aerated to oxidize the iron or manganese, and then pumped through the filter to remove the suspended material. Diatomaceous earth filters are commonly used for the treatment of the swimming pools. Now generally in the pressure filters, the pressure applied is to 3 to 7 kgs per centimeter square. Diameter for the vertical pressure filters, that is 2 to 2.5 meter. For the horizontal pressure filter, it is 2.5 to 8 meter, and rate of filtration observed is 6,000 to 15,000 liter per meter square per hour. Okay. Then you can see here regarding the horizontal and vertical pressure filters. So you can observing here the pressure filter, which is a horizontal pressure filter. Okay, where media you can observe the filter media, sand and gravel, you can see observe like this. So horizontal operation is carried out. The influent is coming. You can see the given here, the inlet you can see, and outlet is provided at the bottom here. Okay, filter media is a horizontal itself, right? So this is the backwash pipe is there. Under drain arrangement is provided here. So this is a horizontal type pressure filter. Then vertical pressure filter you can see. Okay, here inlet is provided. Okay, and outlet is provided here. The media is provided here. More detail provided. Yeah, the same cross section is here provided with the various walls, right? How the pressure is applied, right? So initially the baffle plate is provided here to avoid the disturbance of the filter media. Then this is the filtering surface. Okay, at the bottom this manifold and ladders are provided, and this is the outlet. Okay, at the bottom it is provided with the concrete to give the more stability and support to the pressure filter. Okay, then this is one of the type of the in which diatomaceous earth is provided, especially in case of the swimming pool waters. Okay, such type of filters were used. Earlier, those design of this particular filter starts from the World War II itself. Okay, so during that filter, this particularly invented, and right from that to remove the germs and these things, these types of filters are operated at that time. So you can find the columns of here of a filter in which the diatomaceous earth is used. Diatomaceous earth is used. Now again the rate of filtration that matters very much. So rate of flow controls or flow rates through the filters controlled by one of the two following methods. One is the decline rate and second is the constant rate. Now let's discuss regarding the decline rate. In the decline rate, this method of control is used where head loss through the plant is quite large. It allows the filter head to increase until the filter becomes plugged with the particles and the head loss is too great to continue operation of the filter. The rate through the filter is much greater in the beginning of the filter run than at the end when the filter is dirty. This method tends to be most commonly installed in new filter plants. Constant rate, this type of control monitors the level of water on the top of the filter and attempts to control this level from start of the operation to the end. This is accomplished by the controller operating a valve on the effluent of the filter. The valve will be nearly closed at the start of the filter, runs and fully open at the end. This design is used when the head or filter on the filter is limited. Both controllers consist of venturi tube or some other type of metering device as well as a valve to control the flow from the filter. In most of the cases, the valve is controlled by an automatic control device, often an air activated type valve that is controlling the flow tube controller. Loss of head indicator. As filtration proceeds, an increasing amount of pressure called head loss across the filter is required to force the water through the filter. Head loss should be continuously measured to help determine whether the filter should be backwashed. Usually the difference in the head is measured by a piezometer connected to the filter above the media and the effluent line. Backwash cycle. Proper backwashing is very important step in the operation of the filter. If the filter is not backwashed completely, it will eventually develop operational problems. If a filter is to be operated efficiently, it must be cleaned before the next filter run. Treated water is used for backwash cycle and is generally taken from elevated storage tanks and pumped in from the clear well. Now the filter troubles. Now in spite of taking all the cares and on this, sometimes we have to face some filter troubles. So understanding of that is also very important. But if you are observing the filter operation in the proper manner, so it is quite possible that we may not face these filter troubles. But in spite of that, we will have to study all this. So what are the filter troubles? So these are cracking and clogging of the filter bed, formation of the mud balls, air binding, sand incrustation, jetting and sand boils, sand leakage. Now first one, cracking and clogging of the filter bed. Surface clogging and cracking are observed caused by the rapid accumulation of the solid on the top of the filter media. Cracks are more at the wall junction. So you can see a figure is taken in the sand bed itself, in the filter bed. So such cracks can be observed. So that should be avoided by the proper precautions. Formation of the mud balls. Mud balls are formed because of conglomeration of turbidity, flock, sand and other binders, formed because of insufficient washing and sand grains. Size may be pea size to 2.5 centimeter to 2 to 5 centimeter or more in diameter. Okay, so you can observe this particular combination of the mud balls. Air binding. It is caused by release of the dissolved gases and air from the water from the form bubbles. These bubbles occupy wide space of the filter media, sand and drainage system. It is caused by the negative head loss, warm water and increased DO in the water. It can be minimized by avoiding excess head loss, warming of water, control of algal growth and avoiding super saturation of water with air. Next one is the sand incrustation. It occurs due to accumulation of the sticky gelatinous material or crystallization of calcium carbonate. Sand grains enlarge in size and effective size changes. Carbonization of water can be done to prevent this problem. Sometimes sodium hexametaphosphate can be added to keep calcium carbonate in dissolved state. Next one is the jetting and sand boils. These are produced when during backwashing water follows path of least resistance and break through the scattered points due to small differences in porosity and permeability. Jetting can be avoided by surface wash or air scour. Use of 8 cm thick layer of coarse garnet is also recommended. Okay, this is especially observed during the backwashing. So such jetting and the sand boils. Okay, so the sand layer get disturbed in such cases. So that should be avoided and by taking the proper precaution in the backwashing. Sand leakage, it results when smallest gravels are displaced during the backwashing. Water will enter the under drainage system unfiltered. It can be reduced by properly proportioning of sand and gravel layer. In between the sand and gravel, garnet layer can be used to tackle this type of problem. Okay, sometimes in the backwashing, because of the disturbance of this sand layer, so leakage of the sand may take through the gravel layer, and we are getting the worst effects on the effluent side. Let us discuss regarding now the head loss in the filter and negative head loss. Okay, filter troubles that we have already seen. Loss of head or negative head. So where the when clean bed put into operation, the loss of head will be small, usually in order of 15 to 30 centimeter. Now, as we have seen that when the filtration operation is on, so as the filtration operation goes on there, so filtration rate that goes on declining. So let keep watch on this, and the head loss goes on increasing. So during the filtration, impurities get arrested in the voids, and the head loss goes on increasing. The loss of head can be measured by using two piezometric tubes as shown in the figure. You can see here the piezometric tubes are provided here. Okay, one at this point or here, and the negative head loss also can be measured here. Okay, and total head loss is shown here. So this we'll have to keep watch on this to properly maintain the filtration rate. As thickness or depth of suspended matter on the sand bed increases, the head loss increase. A stage comes when frictional resistance exceeds the static head above the sand bed. At this stage, lower part of sand bed and under drainage system are under partial. So it is clear that we will have to take more precautions here. So as we have discussing these steps, so all the steps are very important in the operation of the filters. As we have discussed the point earlier that the lower part of the sand bed or the under drainage system are under partial vacuum or negative head. Because of the negative head, water is being sucked rather than being filtered. In rapid sand filter, head loss may be 2.5 to 3.5 meter, and permissible negative head may be 0.8 to 1.2 meter. Filter run is terminated and filter is then backwashed when these values are reached. Frequency of backwashing is 2 to 4 days for rapid sand filter in normal conditions. So this backwashing frequency that depends upon the what type of filter is used in the water treatment, and depending on the filtration rate, we will have to carry out the backwashing cycle. So today we have discussed regarding all these points which are associated with the various types of filters. Not only that, we will have to also keep watch on all the filter operations to avoid the filter troubles, and backwashing cycle that should be run properly, and which is necessary to keep observe on the filtration rate to so that this head loss or the negative head loss, this should be monitored. So thank you very much friends for joining this session.